Right, so yesterday we were dealing with this question. We sketched the graph y is equal to square root of x, the graph y is equal to 1, and we chose to use delta y as a representative element. Okay, we chose to use delta y. It was the area bounded by the curve y is equal to square root of x, y is equal to 1, and the y-axis. So that was the enclosed area. Okay, now, first question yesterday was rotating about which axis? Y-axis. Okay, now this one is going to be rotates about the x-axis. Okay. Now, it is just process 1 second. Right, so yesterday we dealt with the area rotating about the y-axis. We drew our diagram. We decided to use delta y. Okay, so now we're dealing with the next question, which is rotates about the x-axis. So if the question states rotates about the x-axis, therefore we need to find delta vx. Okay, now first thing on our checklist is how is the representative element related to the reference axis? That means the axis of rotation. Okay, so let's look at it. The question states rotates about the x-axis. Here is the x-axis. How is delta y related? Is it perpendicular or parallel? It's parallel. Right, so the first thing is we can write down that delta y is parallel to the reference axis. The reference axis, which is the x-axis. So, if it is parallel, then we are going to use the shell method. If it was perpendicular, it was a dis method. Okay. Parallel shell method. Right, so now the formula for the shell method. So what are we finding? Delta Vx, that means rotating about the x-axis. So the shell method is circumference times the height times the thickness. Okay, that is the shell method. So now we know that the circumference is equal to 2 pi r. We need to make sure we don't make a mistake with the radius. Okay. So now which axis are we rotating about? We are rotating about the x-axis. So you take your pencil and you do a rotation about the x-axis. There's your rotation. Can you see that? Just to guide you so you don't make a mistake with the radius. Okay. We are rotating about the x-axis. So the x-axis becomes the center. So the distance from the center to any point on the circumference is the radius. What are we measuring the radius in terms of? X or y? That is the question. Okay, that's what you need to get correct. So the distance from the x-axis is y. If it was from the y-axis, it would be x. So we know our radius is in terms of y then. You follow? Okay. So now, Let's write it down. Our circumference is going to be 2 pi r, so that's going to be 2 pi y. So now the height of the representative elements. The height is the distance from the y-axis to here. So the height is measured from the y-axis. What are we measuring in terms of? X. So the height will be in terms of x. And the thickness of that representative element is delta y. Right. So now this is still delta Vx. We want to get the total volume. The total volume Vx, we integrate, we get the sum of all the volumes. So that will be, now remember this is delta y. So therefore we are still using the y values there. So we're calling the y values d and c. Your constant 2 pi, you write it in front, which is, there's your 2 pi, your variables, so that will be x multiplied by y. Delta y means we are integrating with respect to y. Okay. It's still delta y, we integrate with respect to y. So now, let's substitute. The same y values. What was the y value at the beginning of the area? The beginning was 0 and the highest point, the y value at the end was 1. Okay. So we are still dealing with 1 and 0. So we got dy here. It means integrate with respect to y. So the problem is we have the x here. Can you see that? We must not have any x. So we need to get x in terms of y. So what is x in terms of y? If y is equal to the square root of x, what will x be? Y squared. So that is going to be y squared times y dy. So you have to go and manipulate this equation. So now we got 2 pi, we got 1 and 0, y squared times y will give us y to the power 3 dy. And now this is the easy part, the integration at the end. We integrate y to the power 3, so that will be y to the power 4 over 4, that will be 1 and 0. Simple substitution. So if I substitute 1 there, 1 to the power 4 is 1 over 4, so that will just be 1 over 4 minus, if I substitute a 0, that will just be 0. So therefore I have 2 pi times 1 over 4, which is going to be 2 pi over 4, which is the same as pi over 2. And now we can take out our calculator and round off to 3 decimal places. What do we get? So we get 1,571 units to the power 3. Right, so now, that is not the only way to solve this problem. We sketched our area and we decided to use delta y. Depends on how you are thinking. What happens if you use delta x? We're going to deal with that now. We can, for now, just copy this down and try to make sense of what happened here. Alright, so let's assume now you sketch the enclosed area and you decided to use delta x. So you decided to use delta x here. Okay, so let's start with the one that we just stopped at, rotating about the x-axis so we can see the difference there. So now, The question was rotates about the x-axis. So we know we are finding delta Vx. Okay. The question states rotate about the x-axis. So we know we are finding delta Vx. So now what must we do? We need to check our representative elements. How is it related to the reference axis? Okay. So here is our representative elements. Here is our representative elements, and here is the reference axis. Can you see that? So, is it perpendicular or parallel? It is now perpendicular. So, delta x is perpendicular to the reference axis. If it is perpendicular, what technique do we use? We use the disk method. Alright, so if it is perpendicular, we have to use the disk method. Now, we have already used the disk method for this question, but when we rotated about the y-axis. Now, delta Vx. Now, with the disk method, now delta x lies in between these two. The bottom starts at the point on the curve y is equal to square root of x, and it ends at a point on the curve y is equal to 1. Can you see that? So we are dealing with two graphs now. Right, so we are now rotating about the x-axis. So how are we going to deal with this? We are going to take the volume of the top graph minus the volume of the bottom graph. Okay, because we are dealing with two graphs. So now, take your pencil, rotate about the x-axis. So we are rotating around the x-axis. So our radius, the distance from the center to any point on the circumference, in this case, we are measuring up. So our radius will be in terms of y. Can you see that? So, the volume of the top graph. Which is the top graph? Here's these 2 points here. It's clear that this is the bottom and that is the top. Can you see that? The y value at this position is always greater than the y value at this position. Can you see that? Just by looking at it. This is the y-axis, this is the top, this is the bottom. So the volume of the top graph using the disk method, remember it's going to be area of base times height. So it's going to be pi r squared times h. What is r now? Your r is y. So now, since we are dealing with two graphs, we have to label our graphs separately. Let's call this graph y1 and this graph y2 because they are not the same. y1 is different from y2. So, top graph is y1, so that's going to be pi y1 squared times delta x, pi r squared times h, area of base times height, minus the volume of the bottom graph, which will be pi y2 squared times delta x. Now, we can take out a common factor here. What's common here? Pi is common and also delta x is common. Can you see that? So we take out pi in the front and we put delta x in the back there. So that will be y1 squared minus y2 squared. This is our delta Vx. We want to work out the total volume. So which is Vx. So that will be pi. Now this is delta x. So we need x values. We will label the x values as b and a. So that will be y1 squared minus y2 squared dx. This is the formula that's given to you on the formula sheets. Okay, but obviously you need to know that you have to choose this formula. So now, what are the x values? What are the x values that we are looking for? Here is one x value at the beginning of the area. Can you see that? It's the same as the y value here. The x value at this point here is 0. Where is the end of the area? The end of the area is at this point here. Okay. The end of the area is at this point. We do not know what the x value is at that point. Can you see that? We need to find it, but it's simple. How can we find the x value at this point? Both graphs are intersecting at that point. Can you see that? So in order to find the x value, we will solve simultaneously. Right, so let's do that here. Right, so here you need to solve simultaneously. Right, so our equations, we got y1 is equal to 1 and y2 is equal to the square root of x. Simple. This one is simple. To solve simultaneously, all you do is you take one equation and substitute into the other equation. So all I have to do is take y is equal to 1 and replace it in equation 2. So let's see what happens. So I have 1 is equal to the square root of x. Solve for x, what do I do? This is the square root of x. I need just x. What will I do here? I will square both sides. So 1 squared is equal to the square root of x squared. 1 squared is 1. That is x. Right, so the x value at this point, let's go back here. The x value is 1 when y is 1. So there's our 2 points that we're interested in. 0, 0, 1 and 1. But we are only interested in the x values. So the x value here is 0 and the x value here is 1. Okay. So Vx is equal to, we got pi, that is 1 and 0. Now let's substitute. If this is dx, that means we are integrating with respect to x. We need to get y in terms of x. So this is y1. What is y1? Y1 is just 1. So therefore it's going to be 1 squared minus y2 squared. What is y2? Y2 is equal to the square root of x. So that is the square root of x all squared dx. So now, obviously we need to simplify first and integrate second. 1 squared will give us 1. The square root of x squared, that is just x. And then from here it's simple. We just integrate. So we integrate 1 with respect to x, that will give us x minus integrate x to the power 1, that will be x squared over 2, and we are substituting 1 and 0. So if I substitute 1 here, I'm going to get 1 minus half. Minus if I substitute 0, that will just be 0. Okay, so we don't even need a calculator to work out 1 minus half. What is 1 minus half? Oh, sorry, some of you need the calculator. Right, 1 minus half is just half. Okay, 1 minus half is half. Pi times 1 over 2 is pi over 2. So let's compare. Here's our pi over 2. Can you see that? It's the same thing. So pi over 2 was 1,571 units to the power 3. So this was using delta x. Right, so now you can copy this down. We're going to be dealing with the first question, which is rotates about the y-axis, but using delta x. Okay, so now the question states rotates about the y-axis. So here is the y-axis, our representative element delta x. How is it related? Simple thing to check, because if you get this wrong, everything you'll be doing will be wrong after that. Okay, it's a simple check to do. You have your representative element. How is it related to the y-axis? Is it perpendicular or parallel? It's parallel. Okay, so now let's write that down. So delta x is parallel to the y-axis. If it is parallel, we will be using the shell method. Okay. Now what is the shell method? Let's write it down. Delta Vy, the shell method is circumference times the height times the thickness. Okay. We are rotating about the y-axis. Okay, so you want to make sure you don't make a mistake with the radius. Okay, so all you do is you take your pencil and you do a rotation about the y-axis. We are rotating about the y-axis. Can you see that? So the distance from the center to any point on the circumference is your radius. So what is your radius measured in terms of? Your radius will be in terms of x. From y to there is an x value. Okay. Now, you know your circumference is 2 pi r. So you know r is x then. Okay, so now your circumference is going to be 2 pi x. The thickness, we know what is the thickness. What is the thickness of the representative element? It is delta x. Now this is the important part, the confusing part. Okay, it's the heights. How do we get the height here? Right, so now, here is the height. The height is measured from this point, the lowest point that it touches, to the highest point. It's touching both graphs here. Can you see that? So the height is from here to here. So if this point here was 0.5, let's say y was 0.5, and we already know what is the y value at this point is 1. So if I want to work out the heights, I know that this is 0.5 and I know that the top is 1. What will the height be? It will be the difference, 1 minus 0.5. You follow? Which is going to be 0.5. So in order to work out the heights, it will be the difference in the two y values. So it will be the top y value, subtract the bottom y value. How did we label the top graph? Here is the top y value, this point here. We label this as y1 and the bottom one was y2. Can you see that? So it's going to be y1 minus y2. So now we work out the total volume, which is Vy. Your constant 2 pi, write it in front of your integration sign. So there is your 2 pi. This is delta x, that means we are still integrating with respect to x. So we need the x values, which are b and a, which we already found there. And we have y1 minus y2 multiplied by x, and there's your dx. Now, let's substitute. What is our b and a? We already found that. Beginning and the end there. That will be 1 and 0. What is y1 in terms of x, because this is dx? What is y1? Y1 is what? It's just 1. minus, what is y2? y2 is equal to the square root of x multiplied by x, and there's your dx. So from here, what do we need to do? We have to simplify first. We need to multiply, and then we're going to integrate. Let me give you 2 minutes to do the easy part. Okay, the difficult part is to choose which is the correct formula to use. So now, let me give you 2 minutes to do this. Right, so I gave you time, you needed to simplify first. So we got 2 pi there. That's 1 and 0. 1 times x there will be x. This is x to the power half multiplied by x. We are multiplying and the bases are the same. So you write down the base once and you add the exponents. Half plus 1, which will give you 3 over 2. Okay, simple exponent law. Now we can integrate. So we integrate x, that will be x squared over 2. Integrate x to the power 3 over 2. 3 over 2 plus 1, that will be 5 over 2 all divided by 5 over 2. Here's your 1 and 0. So now let's see what we get. That's going to be 2 pi. So if I substitute, okay, let me simplify first. That is x squared over 2. If I am dividing by 5 over 2, it's the same as multiplying by 2 over 5. So if I substitute 1, I'm going to get 1 over 2 minus 2 over 5. Minus, if I substitute 0, I don't have to show that, you can see. If you substitute 0, it will be 0. So here we get 5 minus 4 all over 10. 5 minus 4 will give us 1 over 10. So this is the same as 2 pi over 10. And 2 pi over 10 is pi over 5. Did we get pi over 5 yesterday? Yes. Pi over 5 is 0.628 units to the power 3. So this is an alternate technique, you can see that. It all depends on how you are thinking in the exam for questions like this here. Okay, you need to look at it. You must decide which technique is better or is faster to use. Sometimes in the exam, the question will state, use the shall method. Then you don't have a choice. If the question states, use the shall method, you do not have a choice. You will have to do it like this here. Okay, but if there is a choice for you, it seems as the this method is an easier option. You'll see now when we're dealing with these two graphs. Let's sketch these two graphs quickly. I gave you the parabolas yesterday. Only takes about a few seconds to do this. Y is equal to ax squared, x is equal to ay squared on the same xy axis. Simple, few seconds.